In this video, we'll take a look at solving a mixture problem using two variables, two equations, and the elimination method. Let's take a look. Sunflower seeds are worth $1 per pound and rolled oats are worth $1.35 per pound. How much of each would you use to make 50 pounds of a mixture worth $1.14 per pound? There's a lot of information here, so we're going to use a table to help set up and organize the information. So under the items we have our sunflower seeds, rolled oats, and then our mixture. We're looking at two variables here, and we need to generate two equations. One of the equations can be derived by using the information here that these two items are combined to make 50 pounds of a mixture. There's no mention of how much sunflower seeds or how much for rolled oats, so we will represent those amounts in the table with S for the pounds of sunflower seeds and R for the pounds for rolled oats. The second piece of information will help us generate a second equation ultimately, and it's listed here that this mixture will be $1.14 per pound. Furthermore, the problem does tell us that sunflowers are selling at $1 per pound, so we can fill that cell in, and rolled oats are selling at $1.35 per pound. To generate that second equation, we're going to fill in this third column. Cost is found by taking the amount times the price per pound. So we're going to take the values from the amount column times the price per pound to give us cost. And let's start with this mixture since it's all in numbers. The cost of this mixture will be 50 pounds at $1.14 results in a charge or a cost of $57. We'll do the same for sunflowers. S times $1 will result in a cost of 1S, or just simply S, and our cost for the rolled oats will be R times $1.35, or listed here as $1.35 times R. The two equations then needed to solve this system will come from this column. The sunflowers plus rolled oats will equal our mixture weight, and likewise the cost of each of these two items will equal the sum of those, which is represented by our mixture's cost. So for the first equation, taking the amounts, we'll take the weight of the sunflowers plus the weight of the rolled oats is equal to the total mixture. And using our costs, we'll take the value or cost of the sunflower seeds plus the value of the rolled oats will equal the cost for the mixture. So here are the two equations that we just generated. The first one talks about the weights. The second one talks about the value or the cost. To use the elimination method, we need to eliminate one of the variables, and probably the easiest, since the coefficient is 1 on S, is to eliminate the S versus the R terms here. We need an additive inverse, so a -1 needs to be multiplied by each and every one of the terms in the first equation to give us an equivalent expression, which is the following. We're now set to add these two equations together, and as desired, the S's do cancel one another out. Combining the R values, we have a 0.35 R, and combining the constant terms is equal to 7. The result is our one equation with one unknown. Solving for the variable, we'll divide both sides by 0.35, resulting in R equal to 20. This is only one of the weights, so we need to use this value, substitute it in either one of the equations to solve for the other value. In place of R, we've put the value of 20 that we found to solve for S, and S is equal to 30. S stood for the pounds of sunflower seeds, and R stood for the pounds of rolled oats, so our answer then will be 30 pounds of sunflower seeds and 20 pounds of rolled oats are to be used in the mixture.